the Chapter 7 review worksheet for pre-calculus. Excuse me. Just some vocabulary for the top part, as per usual. The number of degrees in one revolution is 360. Of course, on the test, what I'm probably asking is how many radians in one revolution, and that would be 2 pi. The range of the sine function, if we haven't changed it or anything, the range is between -1 and 1 inclusive, meaning it's less than or equal to for both of those. Okay. Sine and cosine functions, again, if we haven't changed anything, their period is 2 pi. And the sine and cosine functions are both positive in quadrant 1, both negative in quadrant 3, just a FYI. Convert 315 to radians, so that means we multiply by pi over 180. We reduce that fraction, I believe they're both divisible by 45. And we get 7 pi over 4 for that answer. And then convert 7 pi over 6 to radians. So 7 pi over 6 means we multiply by 180 over pi. The pi's cancel. 6 goes into 180, 30. And 30 times 7 is 210 degrees. Okay. If you remind me to put them on the board, I will give you the formulas. S equals r theta. S is the length of the sector, r the radius, theta. And if we're using this formula, theta must be in degrees. And the area part of that is k equals 1/2 rs. So the sector of a circle has a radius of 4 and a central angle of 3 radians, which means S would be 4 times 3, or 12 centimeters. And the area of the sector would be 1/2 times the radius, which is 4, times the arc length, which we just found, is 12, and half of 4 times 12 is 24 centimeters squared for the area. Okay. For the rest of these, I'm going to go to a separate sheet of paper so I can show my work, as I explained. So number 8 has, you're supposed to find the exact value for the sine of 11 pi over 6. And 11 pi over 6 is going to be down here in this fourth quadrant. 12 pi over 6 would be 2 pi. So 11 pi over 6 would be 1 down from that, the 30-degree reference angle. So this is 1, 2, square root 3, and sine is y over r. And so the answer here is -1/2. Number 9, we're supposed to find the secant of -330 degrees. So -330 degrees is up here in the first quadrant, right? Be up here somewhere. This would be -330, which means what's left here for the reference angle is 30 degrees. So this is 1, 2, square root 3. The cosine of this angle would be square root 3 over 2. Therefore, the secant is going to be the reciprocal of that, 2 over the square root of 3. Number 10, we have the cosine of negative 225 degrees. Negative 225 degrees is going to put me in quadrant 2. It would be negative 225 to here. This is 180. So that is a 45-degree reference angle. So I need to move my paper up, I'm sorry. And so we put in the dimensions. This would be 1 square root 2. And we want the cosine. So that's x over r and negative in the second quadrant. So negative 1 over the square root of 2. And number 11, the cotangent of pi over 2. Well, that's a quadrantal angle. Pi over 2 is up here. And that is the ordered pair 0, 1. And so cotangent is the tangent is y over x. So the cotangent is the reciprocal of that, x over y. So the cotangent of pi over 2 would be 0. Okay. Number 12. Solve cosine theta equals negative 1 for theta in degrees. And again, we're talking about sine and cosine. And if they are 0, 1, or negative 1, then we're talking about quadrantal angles. Okay. And the cosine is negative 1 because it's the x value. It's negative 1 over here at pi. And actually it says they want it in degrees. So 180 degrees. Sorry, I'm so used to radians that was slipping my mind. So cosine is negative 1 at 180 degrees. And then we need to say, it's also then, all the way back to 180 degrees and all the way back to 180 degrees. So how do I include those angles? There's a couple ways. We can say that it's 180 degrees plus 180n, and n has to be an element of the odd integers. We can also say that it's 180 degrees plus 360n, because that's how much of a revolution I need to go to repeat the answer. So this gives me 180, but then I go around again, gives me 180 plus 360. And that would be, if n were 0, I'm at 180 degrees. If n is negative 1, I'm at negative 180 degrees. So that does work. But if I do it, this way up top, then I have to say that n has to be an odd integer. And 0 is not an odd integer. 0 is even. Number 13, we want to write the sine of 150 degrees in terms of its reference angle. So sine is 150 degrees would be out here, right? 150 degrees to there. The reference angle would be 30 degrees because that's 180, and sine is positive in the second quadrant. So we just write sine of 30 degrees. If this were cosine, then the cosine of 150 degrees would be the opposite of the cosine of 30 degrees. And some of you on the last homework I was looking at or something, I don't know where I was looking, but some of you are still wanting to put this negative in here, and that's incorrect. If we're writing our reference angle, the negative goes out here. We take the cosine of 30 and we slap a negative on it. Okay. A lot of times when I make up the review, you look at here, I'm asking you to find the sine of 11 pi over 6. A lot of times when I make up the review, then I just change from, this may have been the cosine on the test, or this may have been a 7 pi over 6, and I changed it to 11 pi over 6. But that's how I make those changes. So you can kind of anticipate a little more closely with these trig tests where we are, as far as what problems might be on the test. So 14, we have the cosine of theta is 3/5. And we want to find the other 5 values. And it tells us that theta is a 4th quadrant angle, which means that x is 3 and the hypotenuse is 5. R is 5. And it is a 3, 4, 5 triangle. We can use Pythagorean theorem to figure that out. 3 squared plus y squared equals r squared. And 25 minus 16 is 25 minus 9 is 16. And we get that. So then we go through and we list all the angles. So sine theta is negative 4/5 because we're in the 4th quadrant. Sine's negative. Cosine theta is what they gave us. Tan theta is negative 4/3. And then we do the reciprocals. So cosecant is negative 5/4. Secant is 5/3. And cotangent is negative 3/4. I made a mistake on number 15. Like I said, when I go in and change these, I'm giving you that the cotangent of theta is 5/3. And then I told you it's a 2nd quadrant angle, which means that this should be negative 5/3. And what I probably did was I probably changed this from sine or something and it being a 2nd quadrant, and I didn't change. Anyway, I didn't change the angle. And they want us to find cosecant of theta. So again, cotangent, and this is the one where they like to try to fool you. So cotangent is negative 5/3, which means that cotangent is x over y. And so the x is 5, the y is 3, and then they're trying to trick you into putting 4 here for the hypotenuse, and it isn't 4. Because using the Pythagorean theorem, 3 squared plus 5 squared would equal that hypotenuse squared. So 9 plus 25 is 34. So the radius is the square root of 34. And like I said, that's a common with tangent and cotangent. We know there are 3, 4, 5 triangles, but even though our 2 sides are 3 and 5, it is not a 3, 4, 5 triangle because the side that is 5 isn't the hypotenuse. In order to be a 3, 4, 5, the hypotenuse has to be 5, and that's not the case here. So then, therefore, the cosecant of this angle is the hypotenuse, or r, square root 34 over y, the opposite side there, which is 3, and cosecant in the second quadrant is positive. So we'll stay positive there. Number 16. We have the inverse sine of square root 3 over 2. So because it's an inverse, there's going to be, exactly one answer. And my domain is restricted to either the first or the fourth quadrant. This is positive, so it's in the first. And the y value is square root 3. The hypotenuse, the r radius is 2, which means this is 1. I recognize that triangle at 60. So 60-degree angle there. And so we would say 60 degrees. Oops. It's set in to find these answers in radians. Sorry. 60 degrees is pi over 3. So that would be our answer, pi over 3. Number 17, we're supposed to find the inverse tangent of 1. And so again, that would put us in quadrant 1. This would be 1, this would be 1, which means this would be the square root of 2. And that means that that's a 45-degree angle. And 45 degrees is pi over 4. 18. The inverse cosine of 1. And again, when we're looking for cosine, sine, and it's 1, -1, or 0, we're on a quadrantal angle. So that's the point 1, 0. This is the point 0, 1, -1, 0, and 0, -1. And the cosine is the x value. So that answer is going to be 0. Had a discussion with one student about could that answer be 2 pi? And technically it could. Well, technically it really couldn't. Because the inverse cosine has to be between 0 and pi. And so if you say the answer is 2 pi, which is at 0, you're really not within that domain. So a little tricky there. Next one, 19, is the inverse secant of 2. And it's positive, so that puts us in the first quadrant. The hypotenuse would be 2, and x would be 1, which means this would be the square root of 3 over here. So that 2 is a 60-degree angle, and so our answer is pi over 3. Okay? And then we have 2 graphs, and that's it. So I don't know why I tore that paper out. I'm going to actually just do these on here so that I'm using the same graph paper that you're going to have. So 3 cosine 2x. The amplitude is going to be 3. That's the number in front there. And also, if you remind me, I'll put on the board the y equals a sine bx. Y equals a cosine bx, and a, the amplitude is a, and the period is 2 pi over b. So the period here is pi. Then we'll get the range when we look at it. Domain is all real numbers. Okay. So if the period is pi, then what I want to count by is the period divided by 4. So I want to count by pi over 4. which we talked about in class. I want you to put those measurements on there then. 3 pi over 4, 4 pi over 4, 5 pi over 4, and 7 pi over 4. And negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4. And then, you know, this is going to be 3, obviously, and this is going to be negative 3 because that's the amplitude. And then the cosine of 0 is 1, but it's 3 in this case because we're multiplying that by 3. And then from there, the cosine graph goes down to 0. And that means that if I plug pi over 4 in, I'm actually going to get 0 because it told me to count by pi over 4. So at every pi over 4, we're going to have something. Okay. So at pi over 2, we're going to have negative 3. At 3 pi over 4, we'll be back at 0. At pi, we'll be back up here at 3, and then back to 0, and then down here, and then back to 0, and then the other way, we fill that in. Let's see, I'm up here, so this will be 0, negative 3, 0, positive 3, 0, negative 3. And it does tell you in the instructions to graph the whole thing all the way from negative 2 pi to 2 pi. So our graph, and they are curves, it's not arrows and lines and corners. And I corrected a couple of people's quizzes who did that the other day. So there it is. Okay. And the range is negative 3 is less than or equal to y is less than or equal to 3. And then lastly, domain, all real numbers, not going to change. The period would be 2 pi over 1, it'll be 2 pi. And the amplitude is going to be 2. Amplitude is positive, it's a distance. What that negative does, I will show you right now. The sine graph starts at the origin, okay? And I should just count by pi over 2. This is just a regular graph. I haven't changed the period. So then from here I go to pi over 2, and usually for pi over 2 I go up to 1. And I'm going to make that, or actually I'm not going to make that. That's going to be 2, and that's going to be negative 2. So pi over 2, normally what I would do is go up here to 2 because if that's positive out front, but it's not. So that means when I plug in pi over 2, the sine of pi over 2 is 1. So when I figure that out, I actually get negative 2. So if I plug in pi over 2, I get negative 2. And then when I plug in pi, I'll go back to 0. And when I plug in 3 pi over 2, negative 2 times the sine of 3 pi, the sine of 3 pi over 2 is negative 1. So when I plug in 3 pi over 2, I get pi at positive 2. And then at 2 pi, I go back down to 0. So going this way, at negative pi over 2, I'll be up at 2, and at pi, and at negative 3 pi over 2, and 2 pi, and that's it. Oh my, I can't. I really missed the boat there on that one. Let's do that again. There we go. And that's what that looks like. In the range, negative 2 is less than or equal to y is less than or equal to 2. And that is the test.